We present object-based image editing for real-time manipulation and animation of static digital photographs. Here is a picture of a Mrs. Potato Head toy photographed against a carpet background. Through the use of semi-automated selection tools, we are able to manipulate individual objects and perform editing operations on groups of pixels in this photograph as though they were created as individual objects in a graphics drawing or modeling application. Notice that when selected objects are scaled down, the background is automatically filled in with textures sampled from the surrounding area. A suite of image editing tools has been created for traditional linear editing operations, such as scaling, translation, rotation, and even object deletion with automatic hole filling. Non-linear operations for stretching, bending, warping, and repositioning have also been created. The selection and repositioning of the tongue in this example constitutes an effective deletion. User placement of anchor points allows us to fix the position of a portion of the object. The user can then grab any point on the object and use it as a handle to bend and stretch the object with respect to the original anchor point. Indirect object manipulation can also be performed using curve deformers for nonlinear control of length, thickness, and rotational bend, providing greater freedom and global control in the manipulation and gesturing of selected objects. Independent selection and manipulation of multiple objects provides the basis for interactive real-time animation of static digital photographs. Object editing requires the object to first be selected and represented as a triangular mesh. Object selection is based on a toboggan-based watershed algorithm. The entire image is first over-segmented into small sub-object regions. Semi-automated collection of these sub-object regions defines the object of interest. Individual regions are triangulated to capture the sub-object detail in OpenGL rendering of the triangular mesh. Object editing requires filling of an object area, such as found within the green boundary, with appropriate background. To explain background filling, consider a selected object surrounded by sub-object regions, called traps, which we will use to fill the space previously occupied by the object, in one of two ways. With concentric filling, traps fill the space through concentric overlapping displacement. Because traps capture the sub-objectness of the background as well, the space is usually filled in a convincing manner. With gridded filling, the space is gridded and filled with randomly selected traps, which overlap onto gridded locations. Following background filling, the object mesh can be manipulated interactively to assume virtually any form or position without leaving holes. Such freedom in object editing is virtually impossible using traditional pixel-based or image warping tools. Indirect manipulation using curve deformers provides both global object control as well as local control for subtle regesturing of the object, after which the object can again be manipulated directly using a thumbtacking anchor point and simple gesture motions with the mouse. Texture painting can also be performed by spraying traps over a region, and can also be used to produce more than a spray of flowers. Individual image objects can be selected and edited both directly and indirectly in a few seconds to a few tens of seconds, in ways not possible or practical using pixel-based editing or polygonal warping. Object-based image editing has caused us to throw out the towel on previous pixel-based approaches by extending the reach of the user and the degrees of freedom with which images can be edited. Object-based image editing should also put a smile on anyone involved in the time-intensive business of keyframe animation and give them a leg up on any application that requires manual in-betweening. Object-based image editing changes fundamentally the way image editing is done by changing the granularity of editing operations from the pixel to the object level.